Hello, and welcome to another episode of Real World Analytics, or What Schools Don't Teach You. Today I'm starting a new series. I'm going to treat an open Kaggle competition as a project briefing and give an overview of how I'd approach the problem as a data science consultant. I'm particularly interested in highlighting the differences between generic entries on Kaggle and a consulting point of view. The Kaggle competition itself is to predict house prices. I'll put a copy of it here. It's an ongoing competition, so I'm less likely to miss the deadline this time. As usual, there's a data set associated with the competition, scoring guidelines, etc. As always, I'll put a link to the competition in the description below, so feel free to have a look through it, and if you hit the pause button, I'll wait for as long as you'd like. So for those of you who looked at it, I hope you found it interesting, and I encourage you to join the competition yourself. It's free after all. And for those of you who just want to hear how I'll approach the problem, let's get started. Today I want to go through the process of defining what I'll do. Now you might be tempted to download the data, fire up your favorite software, be it Python, R, Excel, what have you, but in my opinion you should first outline what it is you're going to do before just charging ahead. So I want to start at the end. What is my objective? Now for Kaggle competitions in general, this is clear. I want to create and submit a text file according to the guidelines. That will get scored, and if I'm happy with the score, I'm done, and if not, maybe I'll go back and tweak my model some more. So that's fine for Kaggle, but it's not what I'll be creating as a professional data scientist. What I'll be submitting is a complete model, including several things. First of all, I'm going to need model development documentation, including the code itself. For Kaggle, no, you don't need to have clean code. You don't need it to be commented. You don't need to have it under version control. It doesn't need to be documented, and strictly speaking, it doesn't even need to exist. Could generate a submission based on the sample by just modifying the numbers willy-nilly, or looking for inspiration from your coffee grounds, for instance, or something else entirely. So of course I'm not going to do that. I'm going to be generating code and documentation, but note, strictly speaking, for Kaggle entries of this sort, you don't need to have a public kernel. Secondly, I'm going to have implementation instructions, including test cases. Now for Kaggle submissions, this is relatively easy. The training and test sets are provided. I'm going to be calculating predictions for each one of those cases. A metric will be calculated, and I can use all these as test cases. And thirdly, I'm going to submit a monitoring prototype. So this is what metric or metrics am I going to use to evaluate my model? I'm going to track that metric over time and use that as a prototype for monitoring. So once again, I have the monitoring information or the metric performance on my public and private leaderboards, so I can use that to confirm that I've calculated my metric correctly. So generally, there's also some business context as to why you want this model. Are you looking to flip houses and you want to track how much profit you're gaining because you have a good model? Are you using it for security evaluation in a banking context? There's almost always going to be some business reason as opposed to just predict house prices. So if you're going to be doing this as a data science consultant, I encourage you to go out and try to get more information about what business metrics are going to be used for this model and incorporate those into your prototype monitoring. A model delivery may also require independent validation, but more on that later. So I'm going to start at the end of this process, and look to deliver all of those things at the end. And it's important that you start at the end because you're looking for what does success look like in this case. In Kaggle, it's that you have a good or the lowest or the best metric. But here, from a business context, what does it mean to have a successful delivery? I'm starting at the end because if you don't know where you're going, you might end up someplace else. So what am I going to need just before delivery? Just before I have the pride and the assurances and happiness of the stakeholders that everything's been done correctly. Well, I'm going to need some assurance that everything has been implemented correctly and that the model is working. So by that, I'm going to need monitoring. So I'm going to want some tracking of metrics so that everyone knows that this model is doing better than it was. That monitoring, again, there would be business context, but I'm just going to be tracking the metric. So what am I going to need just before I have that metric? Well, I'm going to need the model implemented. And note that the final implementation of a model is oftentimes very different than the actual construction of the model. So for instance, if I'm using regression, I need to know the coefficients and the variables that I'm using and how they're all scaled. I don't need to know how I selected those variables. I don't need to know what other variables I included. I don't need to know how much processing of those variables I looked at. I just need the final answer. And so this is where a lot of people in data science would be finished. You create a model, you use its definition to create your predictions, you score the predictions, and you're done. But I think there's a step missing. Before I get a model implemented, I'm going to want an independent validation of my model. So I have a friend lined up, a friend that works in validation. He does this for a living, and he's going to help by providing feedback and independent thoughts about my model. And here, if you'd like to help, please let me know. It's a good idea as a data scientist to have some validation experience so that if you're asked to validate someone else's model, you at least have an idea of what that means. So now I'm going to get into familiar territory for most data scientists. To get the model validated, of course, I need the model. And so all of the talk about artificial intelligence, machine learning, Python, R, deep learning, regression, etc. fits in this one little box that I'm calling build model. It can be a bit, intimidating is kind of the wrong word, but it's a little odd that there's all this discussion about analytics and data science. But from an organizational perspective, that's all this one little box that's called build model. So what do I need to build a model? Well, I need data. The data are free to download, and I might want some auxiliary data sets too, but I'm going to talk more about the data cleaning, data selection, etc. later. And speaking of that, finally, I need to scope all of this out in more detail. So before getting the data, I want to go through and plan out what all of these boxes are in more detail. And that's starting, of course, with this video, which leads me to this define box. All of my other little process steps and this video are just the beginning of define. So now I have an outline as to what I'll be doing and a map for how my work and my videos will progress from here. Of course, you may have other views. Do you think I've missed something? All of these are at a high level. Is that too high a level, or do you think that it could go higher still? Let me know what you think in the comments below, and feel free to reach out to me on YouTube, Kaggle, LinkedIn if you'd like to volunteer to help out with the validation, or if something's unclear and you have some questions. Thank you for watching, and I'll see you next time on Real World Analytics, or What Schools Don't Teach You. Goodbye.